All right. So today is the 14th of April. Look at how close we are to the end. This week, we've just got a class today and Wednesday. Friday, we have a day off, Good Friday. So today and next class, we're covering binary trees. And also on Monday of the 21st. Then we cover generic classes. And we have our last non-final project lab. Then we have some more generic classes. And then we have a review and another review and a final. And on this first review date, the final projects are due. So be ready for all the stuff that's coming. Okay. Any questions? All right. I suppose you'll want to look at the test. So let's do that. Now, I assume you're all happy because your grade point averages did not go down as a result of that test. Nobody's grade point average went down as a result of that test. All right. All right, so let's take a look at how this looks. So the first one, I was, this is our standard sort of tricky thing that we do, where we have a combination of lambda functions or anonymous inert classes, whichever term you prefer, and exceptions, because these things can both play havoc with the control flow of the program. So what we have here are three anonymous inner classes that implement the runnable class, right? And they use this lambda notation that we've discussed. And so this one's going to print apple, this one's peach, this one's lemon. And the way the program is going to work, it's just creating these things. It's not doing anything at this point. So we get here and we say int a equal 3, b equal 4. If 3 is less than 4, test 0 equal test 2. Else, but we don't care about the else because this happens. So now we know that test 0 has been filled in with test 2. Now we're going to say test 0.run. So that's going to run test 2, and we're going to see lemon. And then what's going to happen is, since f is initialized with a null, we're going to get a null pointer exception when this is run, and control flow is going to jump to here. Make sense? Hopefully no one was confused. I'm sure somebody was. I don't remember the statistics. Yes.
The last system that not like what is
grape is here. That's part of the answer. Oh yeah. Yeah, so we're going to get the orange, and we're going to get the grape, and we're going to get the lemon, and we're going to, what's the other one? Lime. No. Lemon, orange, grape, lime. And then we get the lime also because the exception was handled. Any questions there? Just a thought. I saw on the Discord chat, somebody said, "Oh, this question was diabolical." Not this one. This was diabolical. I mean, I wonder how many classes in previous years got this wrong. Many of the questions you see on this exam have never been given to a class before. I'm always making up new stuff. So this is not, I don't come in here and sleepwalk through class, right? I've got it. It's not all pre-programmed. I do try to have it as streamlined as possible, but I'm always changing things and making up new questions. So you can feel special. Okay, this question. So this one tends to be fairly similar from, over time, because it's just so basic and it's just sort of true. It's not quite true false, but it's almost that. right? So selection sort, quick sort, insertion sort, merge sort, these are things that, you know, if I just point to anybody, you should just know it by this point, right? We've gone over it so many times. And you should understand why it's that. You should be able to see why it works. And it goes for most of the things too, right? So selection sort, you know it's n squared because of the work it has to do, and the quick sort because we have log n recursions that we're going to do. A binary search, again, we have log n recursions we're going to do until we find the answer. And then here is testing some basic math. And it always kind of amazes me that I discover people who have trouble with basic math. But in this case, which we want is the dominant behavior of the method, right? So n squared and n cubed is going to dominate. Then if we've got we've got 0.233 times n plus 2 times f of n over 2. If we've got that as our function of time, then we know it's n log n, because that matches the pattern that we've seen before with stupid cough. I wonder if I'm ever going to get rid of it. That runs into the pattern that we've seen before with quick sort and merge sort. And we know that the answer is n log n. And you kind of know that that's going to happen too, because each of those steps, right, those f times n over 2, there's going to be log n of them, right? And each time you go in there, it's going to do the 0.233 times n work. So n log n is going to be your answer. Stupid cough. Adding to the front of an array list. Well, you know, these questions were actually on your last quiz, right? So well, maybe not that one, but we talked about that one just now. So, but all the rest of them were on your previous quiz, and we talked through those already. All right. Any questions so far? All right. We have a bunch of true false questions, and exception extends throwable. That's true. Throwable extends runtime exception. That is not true. Throwable extends exception. That is not true. Error extends exception. That is not true. Throwable extends error. That is not true. Error is a checked exception. That's false. Exception is a checked exception. That's true. Runtime is exception is a checked exception. That's false. IO exception is a checked exception. That is true. Null pointer is a checked exception. That is false. Any questions, thoughts about any of that? Yes, Serene, right? Yeah, so checked exception means that you have to have a try catch around it, or you have to have a throws clause for the method that the thing takes place in. So if I go to open a file in a method, I'm either going to have to put a try catch around the opening of that file, or I'm going to have to put a throws IO exception on the signature of the method, right? An unchecked exception, just you don't have to do anything. You don't have to put a try catch. You don't have to try to handle it in any way. You can just your code can just die, and that'll be fine. So a null pointer exception and array index out of bounds exception have to work this way. Otherwise, every single line of your code would be littered with try catches. Does that make sense? Does that tell you what you want to know? What's that? Yeah, the class exception is checked. Right. So exception and anything that you subclass from exception is going to be checked. And but runtime exception is a subclass of exception, and runtime exception is unchecked. And any subclass of runtime exception is also unchecked. So the hierarchy works as follows, right? If you want to catch, and then you have error, and error is also unchecked, because the reason error is unchecked is because if you get an error, your program is probably supposed to die at that point, okay? And if you want to just sort of generically catch everything except error, you can catch exception. If you want to catch everything including error, you can use throwable, right? And if you want to create a class that people can subclass, if you want to create an exception that is unchecked, you can subclass runtime exception. It's still something that people can handle, right? The notion that you have if you subclass runtime exception is you still expect people to maybe handle your exception, but you don't want to have to put them through the rigmarole of putting a try catch if they don't want to. Does all make sense? Okay. You know, there's this thing when you ask somebody, you know, if they understand something, and you look at the speed at which they nod their head. There's this one, and then there's this one. Anyway, just saying. Yes, Scott.
Still goes with this one is exception kind of includes all the exceptions
Except error.
except error, but because IO exception is not a checked exception. And
IO exception is a checked exception. IO exception is a checked exception. If you open a file, if you go to open a file, you will be forced to put a try catch or a throws clause or one of those things. IO exception is checked.
so why is that one false?
IO exception is a checked exception is true.
Oh, so the three answers are false ones.
No, the three answers are the true ones. Okay, IO exception is a checked exception. That's true.
IO exception is checked. It's null and
Null and yeah, null and runtime are unchecked.
so those are unchecked. But I guess I was thinking because exceptions, all of them is a checked exception.
Well, again, remember, underneath exception, there's a subclass of exception called runtime exception. And anything that subclasses runtime exception is unchecked.
Only if it's specifically that,
Right.
but it will be checked if it's caught in the exception.
Well, no, checked just means that it has to be caught, right? I mean, whether it's caught is independent from whether it's checked. So if it's checked, that means that the compiler is going to check to make sure that you're trying to handle that you're doing something explicit about this exception. You're either putting a try catch or you're putting a throws clause. If it's an unchecked exception, the compiler is just going to say, well, if they want to let this die, I'm not going to say anything, right? So in this class, so a checked exception in this class might be if you say something about a program and it's wrong, I'm going to correct you, right? But if you say something that's wrong about a political issue, I'm not going to say anything because that's an unchecked exception for this class. Does that make sense? So here, let me just do this. All right. Well, let me use a scanner, right? Scanner. Okay. All right, so actually, let's just look at this program again. All right, so what I've done here is I've gone to open a file for reading. Scott, I'm opening this file for reading. Now, when I go to compile this, I get a problem, right? It says unsupported exception, file not found exception must be caught or declared thrown. Okay, because file not found exception is a subclass of IO exception. And so if I want this code to compile, if I want to be able to compile this code, I have to do one of things. I can do this. I can put throws IO exception here, right? I can do that. And now it compiles, it's happy. Alternatively, right, I can do this. And this will also compile, but I have to do one of those two things, right? Yes. Michael?
Yes.
Yes.
Can you do the throws top part? Is that like has any other?
I mean, it means there's something inside the body of this method which will throw IO exception, and I'm not going to handle it. If you're calling me, you should handle it, is kind of what it means. Now, since it's on main, if I put that throws clause on main, that means the program will just die if that happens. Okay, on the other hand, though, if I do this, say int a equal new int 3, a 3 equal 4, right? This is an unchecked exception. This is array index out of bounds exception. And even though that's something that can potentially happen when I index an array, right? The compiler will not stop me. It will not say that I have to put a try catch there because it is not checked. That's what that means. You all get it? Anybody have a question? All right. Questions about hash codes. A hash code of 1 always works. True. It's just inefficient. Remember we talked about that. That's like your hash code. That's like if you went to the library and instead of having a Dewey Decimal System, they just had all the books standing in piles, and you could just keep looking through them until you found the one you want. Yes, that works. You can actually find a book that way. It just is going to take you a while. Okay. So the next one is a hash code needs to be implemented as a recursive. A hash code needs to be based on a random pivot. This is just me combining random concepts in the class that don't make any sense. No, that's not true. A hash code is best implemented as a recursive function. Again, just nonsense, right? If two objects have the same hash code, they are equal. This is false, right? If two objects have a different hash code, they are not equal. This is true, right? So the idea is if the hash code is the same, the objects might be the same. Think about the hash map class that we implemented, right? The point is if they have the same hash code, they're going to be in the same bucket, but they might not be the same thing. Make sense? All right. If it's in a library, Dewey Decimal System, if it's got the same hash code, it might be on the same shelf, but it won't be the same book. All right. If you have a proper hash code, you don't need to implement equals. False. Hash codes can speed up access to an element of a map. That's the whole purpose of them. Sets contain items with unique hash codes. Not necessarily true, no. Sets contain items with unique values. Yes, that is true. Any questions? All right. This question comes from antiquity. So I do give you a mixture of some things new and old. And the idea here, right, if you're trying to figure out, if you get a question like this and you're looking for what should I use as a hash code, what you need to zero in on is the equals method, right? Because the equals method, the hash code is supposed to give you a leg up on the equals method. Now, in this case, the only thing the equals method is looking at is this quantity called spin. So anything that doesn't contain spin is a no-go. And the problem is it shouldn't really contain anything else besides spin because that's the only thing I'm doing for my equals method. So you got to look for something that's going to do no harm to that value. And you get Zorp. Zorp is a final static int. That's great. It's never going to change. It's just 7. So spin plus Zorp is going to work for this as the answer. And nothing else really is because spin plus wheel, well, the problem with wheel Where is wheel? Oh yeah. It's a final static random. And so it's going to be different every time the program starts up. You know, that I really didn't intend for that to be final. The answer makes more sense if it's static. Okay, so spin plus warp. Warp is an instance field, and it's mutable. And so this is going to fail, right? Because I can have things that are going to have a different hash code. If I use that one, I'm going to have things with a different hash code, and they could be the same, right? And that's bad. And cache. Cache is a static int. This is also bad, right? All right. Anybody have any questions about this one? I have one person who has no more questions, and the rest of you have gone into space, right? Yes, Serene. What? Okay, so the concept of a hash code, right? You understand the library example? Yes. Okay, so the point is, I need something that's going to tell me, it's not going to tell me whether I found the thing that I want, but if I'm close, right? So in the case of a library, the first 3 letters of the author's last name and say the category of book, right? That's going to tell me if I'm close. It's going to get me down to one shelf to search, right? One set of shelves, whatever. And that's what a hash code needs to do. Now, if so the thing is, I have to look at the equals method, and the equals method is right here. And the only thing that I'm looking at for the purpose of determining whether 2 of these D table objects are equal is the spin field, right? This thing that I've named spin. And it's just an int. Oh, it's a final int, actually. It's a final int named spin. And I generally want anything that I'm using as for the equals or for a hash code, I want those to be final things. Because if they mutate while it's in a hash map being used as a key, then my hash map is going to not work. It's like if you imagine if you have a book sitting on a shelf and it suddenly turns into a different book, but it stays where it is. Now no one can find that book. So what I need to do, if I'm going to find a hash code, the hash code has to be based on whatever the equality method is based on, right? So it has to be based on spin. And it should be something constant that's based on spin, right? So if I add a random number to it, it's no longer constant. If I add something mutable to it and look at that, it's no longer constant. If I just look at something different altogether, right? Something that isn't any part of that equals method, it's not going to work, right? Does it all make sense? Now, if I just use the number 1, that still works, because the number 1 just means I'm not telling you where it is at all, right? I'm not telling you where the book is at all. I'm just saying go look for it. Yes, Scott.
I picked wheel because it was the final static random. So
You picked spin plus wheel.
Yeah.
Yeah,
Because I was thinking you would want a different number each time, but you would want to finalize it. So I thought the final.
you don't want a different number each time.
Like for the hash code, you have a different number for like new hash code.
You don't want that, right? Because the idea is you want to always be able to find the thing. Now, I could see giving some credit for final static wheel. I hadn't intended to put the word final there. Because what's going to happen is, even though it's going to be a random number every time the program runs, it's going to be the same random number for the whole duration of the program. And so I guess it should work. So I should probably go back and give you some credit for that. But it shouldn't be changing. I mean, you don't want something that's just going to change. The point is, the reason it works is not because it has any randomness in it. That's kind of working against you. Oh, wait a minute. No, I'm sorry. I don't have to give you partial credit for that. The reason is quite obvious. Now that I caught on, right? I was just thinking about the whether it was final and static and whether it could affect finding the book. What I wasn't thinking about, and what's also important, is the addition operator. Spin is of what type? It's an int. Wheel is what type? Random. Can you add those with a plus? No, you cannot. You have to take an extent. And if you take an extent, then it's definitely wrong, right? Because that means that every time I go to look for the book, you tell me a different shelf. And that's not going to make me happy if you do that to me. I will come back with a fish and slap you. All right. Anybody have any questions? Do you understand the concept of hash code? Because you're likely to see that again on the final exam. So just be good to yourself and make sure you really understand it. All right. So this is now one of the things I do in this class when I show you snippets of code is I expect you to understand them. I'm not just showing you random things, right? I expect you to understand the stuff I'm showing you. And one of the ways I test for that is I can show you the code again, and I can leave out pieces of it and ask you to fill them in from a choice in the list. So what you're intended to do with this one, right, is you're going to say if map contains keyword, then I want to say map.put word map.get word plus one, right? Otherwise, I want to say map.put word one. Now, these other solutions here, down here, are things to try to attract people who don't know how the Java language works. You can't assign to the output of a function in Java. It's just not a thing. So, all right. And this one says map contains value word. We want the key to the key is what we're looking for. Okay. Any questions there? What is going on with my answer key? Oh, I see. If you got the two, what this is telling me is, if you did it this way, you get full credit. But if you just happen to reverse this, I gave partial credit. All right. So the next thing is my key, and I was looking for a way. I've asked you this my key question a few different times with ABC and CBA and whatever. All I did here was change it up by switching the characters for numbers, right? It's basically the same question as what you've seen before. So I'm looking on the thing at index 2 first, then the thing at index 0, and then the thing at index 1. And I put compute there, so when it grades it, it actually compiles and runs this code, parses the output, and matches it against one of the answers from my list. So this is my insurance that I don't type something wrong and make the question unanswerable. I try to do that whenever I can. because, you know, I make stupid mistakes just like everybody else. If I took my course and took my exams, I wouldn't get 100%. I would miss stuff, you know. So I don't expect you to be perfect because I know I wouldn't be. But, you know, we've got to measure you somehow. All right. So in this case, we want the thing at index 2 to have the lowest value, right? That's what we're sorting first on. So that's going to give me this one and this one. And then I'm sorting on index 0, right? So that should give me this one. Make sense? All right. My linked list. So what I did here, right, is I just took the same exact code that we looked at in the previous in the review session before the exam, and I just replaced certain parts of it with these little things and asked you to fill them in. And I left in the little picture diagrams, right? So we want C arrow to point to D. So what is C in this code above? Well, C, we said, was the thing that was the thing that we are inserting. So we're inserting a C. Yeah, insert C, right? It says it right there. That's what I was looking for. So we're going to insert C. So where is C going to be on which of those objects? Is it going to be on head or X or link? What is it going to be? It's on the thing we're inserting, right? What's the thing we're inserting? Yes, Michael.
X.
It is not X. The thing we are inserting is link, right? We're taking the value that we're inserting, object O, and we're creating link to hold it, right? So it's going to be held by link. Make sense? You see that, Michael?
What is the link below it?
So link X is going to start with head, and it's going to increment. So link X is going to try to move up to that. So this is the value we want to replace. Link X is going to start here, and it's going to move to there, right? It's going to move until pos -1. So it's going to count up until it gets 1 before the thing, the value, the place where we want to put the C. All right. But the new thing, the new value, the C, is coming in as object O, and that's being stored in the object named link. So we want to say link next equals D. And we know that at this point, X should be pointing to what? B, right? I even wrote it right here. Okay. So it's pointing to B. So we're going to say link.next equal X.next. Right? And then what we're going to say, we're going to have B points to C. So then we're going to say that X.next equals link. Right? No? Have I lost everybody? Anybody okay with this? Raise your hand if you're okay with this. 2 people in the whole, three people in the whole room. This is unfortunate. This is unfortunate. Okay, so somebody asked me a question. Somebody tell me where it's going wrong for them. I need help. Yes, Michael.
I guess maybe like explain a little bit like where everything's going. So I know like the E score, the B kind of check.
All right, so let's take it from the top. Okay, so what we're going to do here, we're going to have pos is equal to 2, right? And we're going to have O is equal to C, right? And we're going to say we want to find the position just before the insertion point. We're going to find the position just before 2. So the way I'm going to do that, I'm going to just start at head. I'm going to have invent a variable named X. I'm going to start it at head. And I'm going to say for int counter equals 0, counter less than pos -1, counter plus plus, X equal X.next, right? That's how I advance through a chain. right? Now I've got X is pointing to B, right? And C is just, and link is just, it's got no next pointer and nothing is pointing to it, and it contains a C. Does that make sense? Who have I lost? Okay. Can you ask me something? After this loop, it's pointing to B, right? Because it's going to pos -1. So it's pos is 2, right? Okay. So pos is 2. I initialize it with head. So it's pointing, and then when I initialize it, it's pointing here. This loop is going to go from 0 to pos -1. Pos -1 in this case is 1, right? From 0 to 1. So it's going to increment 1 time, right? For counter equals 0, counter less than 1, counter plus plus. That's going to happen once, right? So it's going to go x equal x dot next. So it's going to point there at the end of the loop, right? Okay, is everybody with me? Who is not with me? Who is with me? All right, good. All right, so now C points to D. So C, we remember, is the object named link, right? Yes? Yes? Okay. And so the arrow means I want that next thing to point to D. Now, how do I get to D? Well, what I've got is X, and X is pointing to B. But where is X dot next pointing to? D, right? So link dot next equals X dot next, right? Who's with me? Yes.
So it's like you're not. I thought like for some reason I thought it's like you had to like move it. So like you're just like lumping it like without moving things. I don't know. I'm just like confused on like the physical.
Okay. So I think what's confusing you. I can't repeat Michael's question because
Yeah.
let me just say some words and see if they help. Okay, so what is a pointer, right? What is this field called next? And the thing I want you to always think about is this Chinese proverb: the finger pointing to the moon is not the moon, right? So what's in at next is basically it's just an integer. And what is that integer? It's the machine address where the object is stored with the actual value, right? And so what I'm doing when I say link.next equals x.next, there's just a number there that's pointing to a place in memory. And I'm replacing it with a different number that points to a different place. Does that make sense? So link.next equals x.next, right? So initially link.next has got a null in it. It's pointing to 0. It's pointing nowhere. And what I wanted to do is I wanted to point to the place where b.next is currently pointing to, right? That's that D, right? Does it make sense? Serene, you with me? Can you ask me a question? Okay, not sure I know another way to explain it, right? So who is with me? There are some people. I have not lost everyone. And who's catatonic and can't raise their hand? Raise your hand. Yeah, there you go. Okay. All right. So the point is, these things that are of type link, right? These things that are of type link are actually just integers that are pointing somewhere. And the compiler is wrapping some knowledge around that. But the actual storage for the object, you shouldn't think of that as connected to the variable names, right? It's just the variable name is just giving you a machine address to where that object is. And that machine address can be copied around and duplicated. And that's all that is more fingers pointing to the same moon. Okay. All right. If you ask me another question, I can try to put more words, but I don't know what other words to give you at the moment. Do you have another question? You get it in theory. Okay, well that we'll take that victory. Scott, do you get it in theory? All right. Okay, so we have link.next equals x.next. Whoops. Now we want to say B points to C, right? So what is pointing to B right now? Somebody? What is B? What points to B? X. I heard somebody say X. Who was it? Nobody wants to take credit. Terrorist bomb site. No one takes credit. Okay. You know, your protests don't work if you don't take credit for your bombing, but whatever. Okay, so we want B, so that we want the B to point to the C. So we want B.next to point to the C, which is our new value. So what we write is B.next equals link. It's easy as that. B.next equals link. Who's with me? Who did I lose? You... All right. All right, so if something equals null, if something equals null, then tail is equal to link, right? So what do you think that something is? Now I want you to remember in here, we assigned link.next equal to x.next, right? So let's imagine, so we had this thing here. And now let's imagine that B is the last thing in the list. I'm inserting at the end, and this is pointing nowhere. This is pointing to null, and these two things aren't there, okay? Let's imagine that's the case. Then T is pointing where B is, right? So if that's the case, then when I assigned link.next equal x.next, what was I assigning to link.next? What value was I assigning? Are you raising your hand, Logan? No, you're just strangling yourself. Okay. I knew this person once. They had a child who was difficult, let's say. And we were at this restaurant, and the mother said something to correct her, and she says, "I'm always wrong." I thought that seems a little excessive. All right, so what's going to happen is, right, is when I assign link.next, I mean, I need somebody to understand this. At least one person in the room. I'm saying link.next and I'm saying x.next. And where did we just say that x was pointing? X was pointing to B. And what did we say was coming after B? We're pretending this is the end of the list. So these two things aren't there. So where's B pointing? Nowhere. Null. It's got a null. So when I say x.next equal link.next, or I'm sorry, when I say link.next equals x.next, what value does x.next have? Null. So after I do the assignment, what is link.next? Null. And it's null because I'm at the end of the list. Now on my next line, right, I'm going to say x.next equals link. So x.next used to be null, but after this line, it no longer is, right? So what I want to do, if I want to find if I'm at the end of the list, link.next is what I want to put here. Because if link.next is null, that means that can only have happened because I assigned a null here. Okay, and if that's the case, then I have to update the tail to point to the link I just inserted. I need you all to understand that. Yes, Michael.
The one that you got highlighted is just like moving the
copying the pointer. It's copying the pointer. So it's telling it, I'm telling that one where to point the finger. You should point it over there. Okay. Right? Okay. So here's an assignment for those of you who are perplexed by this. Go over it 1,000 times, get with your TAs and understand it, because you need to understand it. All right. If I were running this class like a black belt class, you would not progress to your next belt until you understood this, right? You need to understand this. And whatever you need to, whatever you need to do to fight with yourself, to make yourself understand it, do that. Yes. What's your name?
Brandon,
Yes.
give us a sample method call for insert. Like how we
Yes. Well, okay. So we did this in class several times. So is it this one? Yeah, this is it. Come on, computer. What is going on with you? All right. So this is the class. This is the exact code that I went over in class. All I did was put some covered up and put some blanks in, right? This is the exact code we went over. Right? And you seem to have no question. Nobody seemed to have questions at the time. Right? So so we have link.next equals x.next. Right in here. And this is the exact complete method. Does that help? You remember this? Now, what you could do is you could take this code and you could put print statements everywhere, right? And maybe that would help you if you could just see the values happening, right? But whatever you need to do, whatever you need to figure out in order to understand this code, you need to do it. Because you really can't succeed in computer science if you can't understand this code. Not. All right. And then here is my fill in the blank for the things that are wrong. And I didn't do too well on this one. I made a couple of little mistakes. One of the things, okay, so the first line 0 is include is wrong. In Java, we use import. If you just don't know the word, you're going to miss that one. And this is the only one I got a statistic on. I know that 53% of you got this one correct. So most people got it correct, but not by a huge margin. Line 1 is fine. Line 2, I did this goofy double angle bracket thing here. That's not right. Final int size. I had in mind for this one to be correct, but I decided not to. It's kind of an iffy thing, right? Because line 5 is actually wrong. It should say this dot size equals size, but that means size isn't being initialized, and it's wrong to have something final that's not initialized. So I thought I'd give you a pass on that. Line 4 is fine. Line 6 is fine. Line 7. So what I did there is I changed the get from, I guess it used to be 0 and I changed it to 1, but it really isn't wrong. All it means is I'm initializing things on a different peg. And so I decided not to count that one because I didn't think enough on that. So one of the problems was I have a TA or I have a graduate student I go to and I say, look, take my exam and find all the problems I have with it. And he wasn't available this time. So a few problems snuck past me, like having a number 10 on my list where we only have 0 to 9 on the bubble form. So we're just going to give number 10 a pass there. Any questions on that? Okay. I guess I need to finish up. Wow, we spent the whole class just going over this exam. Okay, well then we had We had regular expressions last, and that's easy. You all understand that. That was humor. All right. Well, I guess we'll leave it there, and we'll talk next time. We'll get deep into the binary trees. Okay.